We are interested in evaluating the following integral. In this integral, we have the integral of dx divided by x squared times 4 minus x squared. So it might be an exam question, it might be a homework question. What's the approach in solving this integral, evaluating this integral? When you see integral like this, if you try to use substitution, like 4 minus x squared, then you have to have negative 2x on the numerator, which you don't. You are not allowed to create some new variables on the numerator out of nowhere. So what should we do? When you see integrals like this, one of the good approaches is using trig substitution. Trigonometric substitution. So for this integral, let us use x to be 2 sine t or sine theta. You can use any variable that you like. Let x be 2 sine theta. Then dx is equal to 2 cosine theta d theta. Then try to simplify this integral as much as you can. So your integral becomes the integral of, on the numerator, 2x is now 2 cosine theta d theta, and on the denominator, you end up with x squared, which is 2 sine theta to the second power times the integral of 4 minus 2 sine theta to the second power. Okay, try to simplify this. Maybe you can get rid of some of these trig functions, simplify your integral as much as you can. So here we go. We have the integral of 2 cosine theta d theta divided by 4 sine squared theta, and on the denominator, the choice of 2 sine theta helped me to factor out 4, because I end up with 4 minus 4 sine squared of theta. Remember that from pre-calculus, if you have sine squared of alpha plus cosine squared of alpha is equal to 1. If you have something like a or a squared or any number, k, anything that you like, a times sine squared of alpha plus a times cosine squared of alpha, you factor out your a and you write it as sine squared of alpha plus cosine squared of alpha. And it is equal to a times 1 or just a. So in more general form, if you have k squared sine squared of alpha plus k squared, it must be the same number, everybody. K squared cosine squared of alpha, it is equal to k squared. Very good. So let's go back to our integral. This integral can be written as the integral of 2 cosine theta d theta divided by 4 sine squared of theta times square root of, so if I factor out 4, I end up with 1 minus sine squared of theta, but 1 minus sine squared of theta is cosine squared. So this integral can be written as the integral of, can we simplify this a little bit further? Of course, why not? This is 2, this is 4, so you get a 2 here. You get cosine theta d theta divided by 2 times sine squared of theta. And then you have square root of 4. Then you have square root of 1 minus sine squared, which is cosine squared of theta. Very good. This guy in turns can be written as the integral of You can combine these two together. This is just 2. 2 times 2 gives you 4. So you have cosine theta d theta divided by 4 times sine squared theta times cosine theta. Okay, perfect. Now I can get rid of cosine and cosine. I ended up with the integral of d theta, or 1/4. You can write down 4 outside your integral. I should have selected something a little larger. Okay, perfect. Equals to 1/4 the integral of d theta divided by sine squared of theta. But remember that from pre-calculus, cosecant of theta is equal to 1 over sine theta. Cosecant squared of theta is 1 over sine squared of theta. So this integral can be written as 1/4 the integral of cosecant squared of theta d theta that we already know how to deal with. This is basically negative cotangent theta. So you end up with 1/4 negative 1/4 cotangent of theta plus constant of integration. But are we done yet? No, we're not done yet. Why? Because our original integral is in x. It is not in theta. So I'm going to copy down our substitution that we used here. Copy. Go down here and make some adjustments. So since x is equal to sine theta, what's the meaning of that? It means that sine theta is x divided by 2. If we go back to the right triangle, based on the definition of theta, this is my x, this is my 2, and this is square root of 4 minus x squared. So this length, which is in front of theta, is x. 2 on the denominator is the hypotenuse. And this length, which is adjacent to theta, is square root of 4 minus x squared. So what's the meaning of that? It means that I can write cotangent. Cotangent of theta, which is cosine of theta, divided by sine of theta, which is basically square root of 4 minus x squared divided by x, and substitute this guy for cotangent here. So your integral is negative 1/4 square root of 4 minus x squared divided by x plus constant of integration. So we look at the quantity that you have in your integral. For example, here, when I take a look at my denominator, I see 4 minus x squared. And I remind myself of pre-calculus. From pre-calculus, I know if I have 1 minus cosine squared, it is sine squared, or 1 minus sine squared is cosine squared. So it has a 4, but if I just use 4, it doesn't help me to simplify the quantity down here. So instead of using sine theta, I'm going to use 2 sine theta. So when I raise this guy to the second power, x squared is 4 sine squared theta. Then when I plug this guy back in here, I can basically factor out 4, and I end up with 4 times 1 minus sine squared, but 1 minus sine squared is nothing but cosine squared. Then we simplify the integral as much as we can, and we remind ourselves of the familiar integral that we learned at the beginning of the class. In this case, we end up with the integral of cosecant squared, which we all know is cotangent, negative cotangent, and it has a 4th in front of it. We just copy everything down. But this is not our final answer, because our original integral was in x. we have to go back to Pythagorean theorem, write triangle, and use the substitution that we decide to use. Our x is 2 sine theta, or sine theta is x divided by 2. Based on the definition of sine, we get the information about the length and the hypotenuse. X is the length in front of theta, which is x, and 2 goes on the denominator, which is hypotenuse 2. Based on that, we can find the other length, which is square root of 4 minus x squared. Again, remind yourselves of the Pythagorean theorem. For the Pythagorean theorem, if you have a right triangle, if this is A, B, C, C squared is A squared plus B squared. So A squared can be written as square, let us just write this down, without square root, and then we add square root. You get C squared minus B squared, so A is equal to square root of C squared minus B squared, which is this quantity that you see down here.